Hello and welcome to this new video. In this new video we're going to learn how to write a Makefile, and especially how to write a Makefile when you have different machines, a 32-bit machine and a 64-bit machine. Now I'm connected to two different machines. One is called Tools and the other one Gandalf. You see that if I use the uname -m command, you will see that one is a 32-bit machine, the Gandalf machine is a 64-bit machine, while the Tools machine is a 32-bit machine. So then I've also written a Makefile that when I compile the file now on the 64-bit machine on Gandalf, it will create the binary. So it's exactly, we're sharing the same folder, same file. So I'm compiling a file, I'm running it, and it's working fine. Now I'm going to rerun the file, the binary file generated on the 64-bit machine on the 32-bit machine, and it's not working because the file was compiled on a 64-bit machine. Now, if we do the opposite, if we actually make clean, I recompile now the file on a 32-bit machine, and you will see that it will work on both machines. 64-bit machines can run 32-bit binaries. So now we have compiled the file. We will compile the file. So make clean first. You see that the binary file is gone, and now we're going to compile it on the 32-bit machine. You say make on the, and you see the -m32. That's what you need to compile a binary in 32-bit machine. And the Makefile automatically detects that is a 32-bit machine. So that's why it adds that option. We're going to learn how to automatically detect that option, detect what kind of machine it is. So it created the binary, it runs on the 32-bit machine, and when we run it, the same binary now that has been generated because of the shared folder, also the 64-bit machine also has access to that. We execute it and also runs on the 64-bit machine. So it runs on both machines, right? So then how can we write a Makefile that detects automatically what kind of machine we're working on? So this is a Makefile. So this is the target, the binary that we just generated, and so we assign the variable target, call it target, and then we add the source files and the header files. So if you look into the machine, you see this is the CPP files that we just compiled, and these are the header files. And now the important thing is here. So we added to the Makefile the Linux command, the uname command that I showed you before. So first we check what kind of machine it is. If we can't understand what kind of machine it is, the uname command returns something that is not null. It's if we're working on Linux, for example, not in Windows. And then we assign the type of architecture to a variable called CPU architecture in this case. So this is, we call again the uname command -m, and it returns if it's a 64-bit machine, it returned x86_64, and if not, it will return something else. So in this case, we set some paths that we need in our binaries to the 64-bit library or the 32-bit library, depending on what kind of machine it is. Right? And we add the compiler flag -m32 for the 32-bit case. So we declare some other variables that are not important in our case, like some architecture for system C. In this case, we're compiling a system C file, and we add, again, if it's a 64-bit file, we can compare the variables and so on. We add some other variables there, and with the if definition, if-def, we can now see we're checking for system variables declared in our Linux system, so we can do that directly from the Makefile. And based on that, if we find those libraries, we can assign different values. We check now if GCC is installed or not. If it's installed or not, or we assigned our own path for G++ in this case. And this is the main part now of the Makefile. So we have the target, we compile all the files, and we link the files. So we first obviously have to compile to create the object files, and then we have the linker. And we have different versions now. We can have the normal version, the release version, or the debugged version, where we need the -g command. So if we type g make debug, it will call the debug version. And if we call make wave, we're declaring now a variable called wave flag. And where is the variable declared? If we go to the main file, main CPP, we declare inside of the source code an if-def statement, a pre-compiler directly called wave dump. And you see that wave dump. Whenever we call make wave, that -d, and the name of the variable will be set. We're defining that variable. So that part of the source code just highlighted will be taken into account by the compiler. Right? So we say make and make wave. Now you see the -d wave dump variable has been added, and now it's compiling that part of the code in the CPP file that was defined within that if-def statement. So you see now it created some other files. In this case, is a VCD file for the simulation. So that's the good thing about Makefiles. It allows us to generate different targets, like a release version, a debug version, or a waveform, or add some. With if-def statement, we can control different Windows version versus like a Linux version and so on. No? So now we're saying make clean again. And you see here, these are, if you say make clean, always very useful. It deletes all the object files and the binary files just compiled. So I hope you liked the video. If you have any questions, you can drop me a line. I'll be more than happy to answer them. And I hope you enjoyed watching it. Thank you very much.